our next speaker is already ready. It's George from Western Digital, and with him we will touch a completely new topic today. So we're gonna talk about integrated artificial intelligence in robotics. So in his role as Regional Director of AI and IoT, George is responsible for a lot of different projects around big data analytics, and also involved in the strategic program management. So I'm pretty sure he has a exciting story to tell. George, the stage is yours.
All right. Thank you, Andrea. Let me share my screen.
Mm-hmm. Okay, we can see your slides. Perfect. So ready to
go. Okay, good. Thank you. Thanks again, Andrea, for the introduction. So good afternoon. I'm George. I'm responsible for analytics and smart factory implementation at Western Digital. So this is the topic that I'll be covering and sharing with you today. So before we get started, I thought to cover 3 items today. And first is I'll give you a little bit of introduction to start off, about Western Digital, and how we manufacture a HDD, a hard disk drive, before we get into discussing those use cases. So in general, we see that the data is the engine of a global economy, and is enabling a rapid growth in the volume, velocity, and value of data. And data creation is growing exponentially, and it continues to grow into a zettabyte age. And data continues to be created by various devices, machines, and etc. And data creation, is transforming in various industries. It's actually fueling the disruption in our world that involves mobility, IoT, AI, autonomous vehicle, augmented reality, industry clouds, and etc. Right? However, the landscape, the data landscape continues to evolve. We see data in 3 areas. The core, the edge, and the endpoints. Big data generally, how we see it falls on the core, or the cloud computing, to do those heavy lifting of data processing, data transformation, data retention, and model development, and so on. While some models are deployed at the core, but some models are also deployed at the edge or at the endpoints, to shorten the decision latency, and to for certain type of use cases that are requiring what we call as fast data. So it's important to consider appropriate infrastructure in which is critical to a data-centric world, so that everything stored and analyzed, it can be faster and more efficient. So Western Digital's focus is to be a data-centric infrastructure company. We have a broad portfolio of data storage technologies, products, and services, and we continue to focus on technology and innovation, and continue to generate value to our customers. So we focus on breadth and depth of product portfolio and solution to capture and preserve, access, and transform data. By expanding the scope of innovation to encompass software, processing, interconnect, storage, mechanical, and manufacturing disciplines, our approach offers purpose-built products that provide the performance, reliability, most importantly, the total cost of ownership and sustainability demanded by data-centric environments today and for tomorrow. We are a about 65,000 employees worldwide. We have manufacturing operations around the world that includes wafer fab, assembly, and test manufacturing. Most of our manufacturing sites are located in the Asia Pacific region. Some of it are in the United States, but majority in the Asia Pacific region. So now, let's get into the, before I get into the case study, and I thought it would be good that if I could give you a little bit context, of how we manufacture a hard disk drive, before we actually get into the case study discussion. Okay, so to manufacture a hard disk drive, there are many components. These are all the components that that's involved in manufacturing a hard drive, and involves many different suppliers of ours, that helps us across the region, and many of them, and to help us manufacture each of these components, and then we of course we design it, and then after that we assemble it and make it an end product for us. In general, HDD is basically a nanotechnology that enables mass storage. It's about storing and retrieving digital information that's stored in the magnetic bits on the media. And the head is basically the transducer to convert electrical pulses to magnetic transition and vice versa. And the media is to store the magnetic transition as magnetic bits. If you imagine, if any one of you have seen a hard disk drive, you open up the cover, then you see that there's a brown rotating media, which looks like a mirror. And then we have the head component that reads and writes. And then you actually, if you imagine, it's like flying a jet plane a few inches off the ground, when all the reading and writing happens. Okay. So jumping into the case study, which is the purpose of today's discussion, is we have the drives towards a data and insight-driven company. So we aspire to improve our data latency, analysis latency, and the decision latency. We are building a smart factory network that is engineered to self-optimize, self-adapt, have autonomous run capability, and most importantly, to be able to learn from new conditions real time, which is very critical in any typical manufacturing or factory. And we want to integrate all the processes that we have, our product, our physical machines, and automation all together for real-time decision orchestration. And we see smart factory, generally relates to two components: the automation and the intelligence piece, which is the AI part of it, or call it analytics. In manufacturing, automation is probably a common thing to us, especially in the context where we manufacture, when we manufacture a HDD every few seconds. That's how long it takes to put a hard disk drive together. And then the AI piece is which I believe most of us are excited because it's creating a lot of new opportunity for us today, for all of us in this world. However, we see it's important we integrate both automation and AI together to help us create a new level of operations improvements, which that will help us self-distribute, self-correct, and self-running. So if we take automation to the highest maturity level, it actually helps us, to achieve a near lights out manufacturing. Lights out manufacturing here means, we really switching off the light, literally in the factory floor, meaning it's dark. So you imagine when you're at the condition, meaning everything is running autonomously, everything is robotic based. Yeah, that's where the intelligence, is very important to help us, adapt and manage a situation on a real-time basis. And then, so taking, like I mentioned just now, the importance of automating and be able to achieve a light-cell manufacturing is important, to achieve an analytics and an intelligence level to the highest maturity level to help us augment intelligence in a complex manufacturing environment real time. If some of you who are in the manufacturing, you know that it's not easy to manage a manufacturing because at a constant basis, there's a lot of scenario that changes, a lot of situation that that's new, that we have to constantly figure out on a real-time basis. What will be the right next best action to take, right? So automation is not the only answer to all that, right? So analytics is the part that infuses intelligence, into the whole process, to help us, manage all this. So this is why, we see it this way, right? So the factory of the future has a lot of evolving definition, as you know, even different names. Some may call it smart factory, smart manufacturing, industrial 4.0, many terms, we just chose to call it a smart factory network. The factory of the future is really, to us, a product of fast changing, disruptive technology hitting manufacturing. Actually more like a tornado, right? AI, artificial intelligence use cases are becoming more increasingly powerful nowadays and adopting more of an applied focus in many fields, which is, in this context, this is manufacturing process control. And automation has come a long way, this recent years too, right? But what happens when you put, the circle on the right, the AI, the blue circle, and the orange circle on the left, which is automation together. So both of these developments brings a vision of autonomous manufacturing, autonomous production within the reach of first time, if you think of it. Machine learning algorithms running on embedded hardware are now becoming an option for us to help us achieve an autonomous self-adapt, self-optimized capability. Okay, so this is the case study that I wanted to share, right? So this is one of the case study example that involves a hard disk drive clamp install tool where AI is embedded into the tool to automatically adjust and minimize and self-learn. So in hard disk drive HDD, imbalance can affect the drive performance. So what is imbalance? Basically, just imagine imbalance is the rotating media that I mentioned just now, the round shiny thing that looks like a mirror. So during installation, it's important for it to be installed in a way that is balanced. So you just imagine that rotating media is like the wheel of your car. So from time to time, your car will require, if you feel that, it's not driving right, then, you send your car, so that your tire get alignment and balancing. So it's the same scenario here, but you don't need to, make those changes from time to time, but, it's just a one-time thing. But you just imagine that, the imbalance here means it's an alignment of a car tire. So imbalances, can cause a misalignment error when reading data, writing data to the disk, in a hard disk drive. So imbalance may also generate vibration and noise. So it can vary from drive to drive, and it can be unpredictable, sometimes if it's not assembled correctly. So it's very important for a hard disk drive to have a balanced rotating disk pack to meet our stringent product specification. So, to secure a disk to a HDD to minimize imbalance, a clamp is placed on the top of the disk, right? So the circle that you saw that you see in the previous page just now, and then it's secured by screw, and we need to make sure that the center, of the disk, right? And then the drive is balanced by biasing the disk to the opposite side of the unbalanced clamp. The disk clamp installed too during the assembly process. So the drive imbalance is then measured back, to check whether it meets the specification or not. Right? It's crucial to have the disk clamp placed exactly at the center of it, to achieve a desired balance, so that it'll be challenging when the imbalance spec, which is very tight, and coupled with all those variation that we're getting from our supplier, all those components and material we get, and plus the two conditions, it becomes very challenging for us to manage. This is what we have been experiencing, right? So previously, when this happens, the engineers and technicians will constantly monitor, this performance, and when the failure rate gets increased, and then that's where the engineers and technicians are triggered and say, hey, that's the failure rate has gone out of what is expected, and then the engineers or technicians will attempt to make adjustment, right, to the tool, so that we could make sure that this clamp placement is good. So this is an iterative process, until the failure rate improves. So now what we're doing is, we have embedded machine learning into the tool through an edge device. So that automates the previously manual intervention process. So the algorithm now monitors the imbalance performance real time automatically, and then it automatically predicts what will be the new optimal clamp placement position, meaning the tool setting, and then it will adjust the tool setting automatically. And you imagine that we no longer need a manual, we no longer need the monitoring. We no longer need engineers or technicians to constantly look at it or to make adjustment to the tool, so that we we will keep the failure rate as low as possible. Now everything is taken care by the machine learning algorithm that's embedded in the tool. So we are basically embedding the AI into the tool and the process. So since implementation, we've seen more than 60% improvement, and to a baseline, and we were very happy with this implementation, and then we have been proliferating this to all areas in our manufacturing process. Not just to this manufacturing steps. So and like I mentioned, it didn't stop here, right? So there are many other areas that we are augmenting intelligence into the manufacturing process. We are embedding the intelligence, and we are infusing analytics and machine learning into various manufacturing process throughout our factory. These are some of the examples that involves an end-to-end integrated use cases for our manufacturing process. That involves the material side of it, the assembly process, the test process, as well as the quality. So of all the things that's done, right, how do we manage this, right? How do we deploy and such a implementation? So we manage all this implementation through a scalable solution architecture that covers both the big data and fast data elements, as I mentioned earlier. Right, depending on the types of use cases and the type of use cases where the data latency requirement is, some may resort into a big data, the core cycle of implementation. Some will involve the fast data side of implementation, will include the edge, or the endpoints, right? Okay. And lastly, the factory of the future, will always rely on people, right? It provides the potential to innovate and grow to do more challenging tasks. So the autonomous technologies, can cater to what is repeatable, and which is what we have implemented. And the ability to innovate on products, respond to markets, or even cater to experiences that product creates will be an important aspect for consideration. So a creative mindset for problem solving and out-of-box thinking, is the key, for all this type of innovation. And the factory of the future, will be far more data-driven and agile, I think, moving forward. And it's the new beginning, for manufacturing. And it's important. Most important is, you are creating an environment for data to thrive. So that's all I have today. Thanks for your time. Hope you find this relevant.
Thank you, George. So it was really good or interesting insights. I'm just checking if we got any questions for you. So please, everyone, if you have questions, just note them down in the Q&A box, and George will be happy to answer. Okay, I think you will stay a while with us, so in case something comes in, you can still answer them. So yeah, thanks again, and have a good day.
Thank you. Thank you, Andrea.
Good. Okay.